Man, I hate game days at UVA. Ubers are expensive, bus transportation leaves at the most inconvenient times, and all I want to do is drive my car and park without having to worry.
I know, all the signs around here are just misleading, like you never know what's legal and what's not.
You know what? Screw it. I think I'm just gonna go for it. What's the worst that can happen? There's no way to tell whether I can get a ticket anyways.
Yeah, just go in. Alright, I guess it's fine. Let's just head into the game.
Man, I really hope it's fine. Last time I parked at the game, I got a parking ticket for $150. What do you think this means?
I have no idea, honestly.
But as we begin here, just your thoughts on what ultimately cost your team this afternoon.
Man, that was a really tough game. I mean, I thought we were gonna win that one. Definitely not lose by 50.
Yeah, and they just rushed the field. Almost got trampled by those guys.
Yeah, and it really sucked when the nachos just spilled all over my lap and I got nacho cheese all over the place.
How could this day get any worse, man?
What happened here? What are all these tickets? I can't afford these.
Yeah, if only there'd been a better way for us to know we can't park in this spot. As students living in Charlottesville, we heard the cries of concern over people not being able to find where to park, most importantly getting parking tickets and having to pay the money. This is not only on game days, but every day. So we wanted there to be a more practical solution. This is exactly where our project started.
So we started off by identifying a problem within our community. People didn't know where they could park without a fear of getting a ticket. The signs were limited, confusing, and overall led to a significant amount of tickets. While this may be good for taxes, this is horrible for residents of the Charlottesville community. Getting a ticket may be taking away a paycheck they desperately need.
So our solution was to build a tool that could use Charlottesville parking ticket data to predict for people the reason that they're most likely to get a ticket. And this would be based on the data that has been taken by the city of Charlottesville over the past few years, run it through a machine learning solution, and by the factors that are listed in the data, such as time, street, year, month, you will be able to predict why you'll be getting a ticket. Therefore, you should be able to avoid these costly expenses.
We began to build our model by experimenting with a number of different types of models. After testing, we decided that a neural network works best for our multi-class classification problem. While building this model, we encountered some unexpected problems. For instance, some of our features were categorical variables, so we needed some way to encode them to fit as inputs to our model. We decided to use one-hot encoding, which essentially allows each class of the categorical variable to become its own feature, with values of 0 and 1. An issue with this is that it makes our training data rather sparse, being mostly zeros. After extensive testing, it was decided that this consequence is worth the benefit of using one-hot encoding. Another major problem with our model is called, as we came to find out, imbalanced classification. This means that our data's violation description label is imbalanced because one of the 23 classes of violation description corresponds to about 40% of our training data. This problem was evident in our confusion matrix. Our research led us to something called class weights. Class weights modify a loss function in order to penalize false positives of some classes more than others. In this way, we could artificially force our model to spread out its predictions from the most prevalent classes.
That we used was able to get about 68% accuracy. This allowed us to create a confusion matrix and plot it that looked much better than the initial one before we modified the data. As you can see, this column here is a lot more prevalent in the data, as we mentioned, because violation description number 9, which we encoded, is the most common data point. However, ultimately, we do get about, as I said, 68% accuracy. So in using this machine learning model, you would be able to predict based upon the qualities that you import into your model, which we explained earlier were the year, the time, the weekday, the month. You would be able to predict the violation description with about 70% accuracy.